Bismillahirrahmanirrahim. Assalamu alaikum everyone. This is Falak Chaudhary from Department of Chemistry, University of Education, Lahore. And today I am here to discuss about the topic of the course Inorganic Material Chemistry, course code Chem 3115. The topic that we will discuss from this course is the chemical properties of the advanced materials. And in chemical properties specifically we will discuss about the corrosion properties of the advanced materials. In this lecture we will cover or go through the chemical properties, the corrosion properties, the whole process of the corrosion, and lastly we will discuss about the methods to prevent the corrosion. So let's begin our topic. So firstly we will discuss what are the chemical properties. Chemical properties are basically related to the behavior of the materials, that how a material interacts with other materials, that means its response to other metal or its lack of response. The chemical properties includes the reactivity of the materials, the reactions which it undergoes, and certain materials behave differently with different substances under different environment. Just like if we discuss about the reactions with water, then for example sodium metals react vigorously with the water. On the other hand, plastics show inertness towards the water. These are the chemical properties of these materials. And also the reactions with acids, some metals react vigorously or some substances react vigorously with the acids, or others don't react in such manners. These are the chemical behavior of the substances. And the chemical behavior or chemical properties also includes the burning or flammability properties of the materials. And what is that flammability? Flammability is basically the ability of a substance to get burned. We can take the example that in our laboratory we have certain solvents that easily catches fire, and mostly these are the organic solvents which catches fire easily, and these are due to their chemical behavior, their chemical properties, that they catches fire easily. And the chemical properties also includes the reactivity of the substances, their coordination number, and the enthalpy of formation, and also how toxic a substance is, that how it affects some other substances. These all are included in the chemical properties of the substances. And lastly, what is the corrosion and oxidation? It is also a chemical property of the substance that is over today's theme of discussion. So let's learn what is the corrosion or oxidation property. Corrosion is basically what that under corrosion a material or metal deterioration or surface damage is an aggressive environment. That is that when a substance is exposed to the aggressive environment, its surface gets damaged and it gets corroded. Just like you can see here, there are some things of the iron that is shown, and these things are corroded due to the process of corrosion. Their physical appearance, their durability, their strength, all is affected due to this corrosion process. So what this corrosion process is? Let's see that. Corrosion process, it is a chemical and electrochemical oxidation process. Just like in the previous slide we have seen that with the corrosion is an oxidation of what? Oxidation of the metal. Basically the redox reactions take place in the corrosion. Metal surface get oxidized by the transfer of electron to the environment, and the other species get reduced.
An aluminium toy, an iron nail, a copper pipe, and a gold ring are left out in the open for many years. Which of the four materials do you think will be in the best condition when they are rediscovered? Pause, think, and continue when ready. If you think the gold ring is likely to be in the best condition, you're right. The copper pipe and the iron nail will appear in a worse condition, but the aluminium toy is also preserved very well. Most likely, the iron now will appear in the worst condition. This is because of corrosion. Corrosion is described as formation of compounds on the surface of a metal when it is exposed to air and/or water or an electrolyte, like salt water. Typically, once a metal corrodes, it forms compounds known as oxides or hydrated oxides. The now, made of iron, rusted. This, by the way, is the only time you should use the term rusting. All other metals are considered as having been corroded when they react with water and/or oxygen in the air. But why would the now be more corroded than the aluminium toy, the copper pipe, or the gold ring? Have you any ideas? Pause the video and continue when ready. The reason is, the metals all have different reactivities. Iron corrodes faster because it is more reactive than the copper and the gold. But you may be wondering, well, why didn't the aluminium toy corrode the fastest? The truth is, the aluminium is more reactive than the iron, so it reacts fastest with the oxygen from the air, forming aluminium oxide. Aluminium oxide is very unreactive because once the oxide layer is formed on the surface, it binds very tightly to the surface of the metal, so no cracks can form and cause further corrosion. Here's a challenge. How might you use this idea to protect the iron now? The answer is that by covering a metal like iron with another more reactive metal, like zinc, is that the zinc forms the zinc oxide layer quickly. The iron underneath is protected. This process is called galvanizing and can last up to 100 years. If you think of the metal on a bike, corrosion can be prevented by painting the frame, a static part, or greasing the metal parts, like the chain, which moves, or by covering it with a thin layer of a less reactive metal, like tin, copper or gold, but that would be very corrosion can be prevented by painting the frame, a static part, or greasing the metal parts, like the chain, which moves, or by covering it with a thin layer of a less reactive metal, like tin, copper or gold, but that would be very
So we will see the process of the corrosion, and now we will see the natural passivity or the resistance of the material to the corrosion. As we see in the previous example, that the nail or a bicycle is prevented from the corrosion by galvanizing or painting. But there is natural a property or the ability of substance to get natural pacify from this corrosion process. What does it happens? This occurs when the metal reacts with the oxygen in the air. When metal reacts with the oxygen in air, it forms a oxide layer on the surface of the metal. This thin oxide film that blocks the metal tendency to undergo further reaction. That means it is prevented. This layer prevents the metal from exposure to the environment, and thus in turn it helps to prevent the metal to get corroded. For example, if we take the example in the previous video, in the previous animation, we have seen that the aluminium metal or aluminium car is not get corroded due to the formation of this aluminium oxide layer. This layer is highly impenetrable. That's why the metal is not exposed to the environment and lasts long. So see that oxidation of aluminium gives a hard, impenetrable film of aluminium oxide which protect it from further contact and reaction with the oxygen. But in certain cases, protection fails. If the thin film is damaged or destroyed, then the material is again exposed to the environment and it gets corroded. And to this process we can say that this material get repassivate. It loses its natural passivity and it get repassivate. So what the corrosion is? So basically corrosion deteriorates or damage our economy because global iron production is greatly damaged by this corrosion process. So we have to prevent this process. To prevent corrosion, we have to understand how it occurs. We basically have to understand the whole process of the corrosion. That's why we will be able to avoid the corrosion process. So what is it? Rusting of iron requires both oxygen and water. In the absence of any of these things, we can avoid the rusting process. The rust is not formed by direct reaction of iron and oxygen, but rather by an electrochemical process in which iron is oxidized in one region of the surface and oxygen is reduced in another region. So corrosion or rusting occurs both in the presence of oxygen and in the presence of water. In the absence of any of these materials, the corrosion does not occur. Let's see.
A simple experiment. Place an iron nail in 4 test tubes. Fill one with regular tap water until the nail is submerged. Fill another with regular tap water and add half a spoonful of sodium chloride, regular table salt. Shake from side to side to ensure that sodium chloride fully dissolves. Fill the third test tube with recently boiled water and add a thin layer of oil. When we boil the water, we remove any dissolved oxygen, and the layer of oil prevents any oxygen from further dissolving. In the last test tube, add a spoonful of calcium chloride. Calcium chloride removes moisture or water. So in the first test tube, the nail is exposed to oxygen and moisture. In the second test tube, the nail is exposed to oxygen, moisture, and salt. So in the third test tube, the nail is only exposed to water. In the fourth test tube, the nail is exposed only to oxygen. Stopper all 4 test tubes with a rubber bung and let stand for a couple of days. You will find that the nails in the first and second test tubes have rusted. In particular, the nail in the second test tube has rusted more than the nail in the first test tube, and the rust has likely flaked off. You may see a reddish-brown precipitate at the bottom of these tubes. The nails in the third and fourth test tubes have not rusted. So what has happened here? The iron has undergone an oxidation reaction, forming hydrated iron trioxide or rust. Salt and acid act as a catalyst for this reaction, which is why the nail in the second test tube formed more rust than the nail in the first test tube.
So we will see in the last video that when the iron nail is exposed only to the water or only to the oxygen, it don't get corroded. But in the presence of moisture and in the presence of both the moisture and the oxygen, the iron nail gets rusted. And in this video we will learn other things, that in the presence of salt, metal gets corroded more. This explains nicely why automobiles rust more rapidly in places where road salt is used to melt snow and ice. We can take the example over northern areas, just like Murray, where salt is used to melt the ice on the roads, and in that areas automobiles are corroded or get rusted more than other areas. So what happens there? Dissolved salts in the water droplets greatly increase the conductivity of the electrolytes, thus accelerating the pace of corrosion. Thus accelerating the pace means the speed of the corrosion. So we can say that the salt acts as catalyst in the corrosion process. Next,
find out more. The rusting of iron is an oxidation reduction reaction. Here we can see the iron being exposed to a water droplet containing dissolved oxygen. This exposure causes each iron atom underneath the water droplet to give up 2 electrons to become iron 2 ions. This process is known as oxidation. Next, electrons are released and flow throughout the droplet, where the oxygen dissolved in water receives electrons to form a hydroxide ion. This is the reduction process. Next, iron 2 ions combine with hydroxide ions to form iron 2 hydroxide. Finally, iron 2 hydroxide reacts with water and oxygen to form iron 3 hydroxide, which is also known as rust.
So here you see that rust is formed. So next we will discuss about the prevention and control of this corrosion process. As we have thoroughly understand this corrosion process, that iron is get oxidized and it forms the rust on the surface of the metal, which reduces the strength and the appearance and durability of the matter. So how we can prevent this corrosion process? Let's see that harmful corrosion can be prevented in numerous ways. So what these ways are? By shielding the metal surface from oxygen and moisture. As we have seen that in the presence of both oxygen and the moisture, the metals get corroded. So by shielding the metal from both these things, we can prevent the corrosion or rusting process. For this purpose, we can do what is the paint the surface. Paint the surface means it prevents the direct exposure of the metal to the surface, but this paint is not effective for a long time, because if the paint surface is stretched or chipped, then soon the material gets exposed to the environment and it starts to get corrosion. So in order to avoid this process, we'll use another process which is called the galvanizing, in which electrical currents are used to produce passive films on the metals. These passive films are basically of the oxides or some other things that helps to prevent the metal from corrosion for a longer time than this simple the painting the metal surface. And some other things and some other techniques are available, just like treatment of the metal with lasers to give a non-crystalline structure on the surface of the metal, which resists the corrosion of the metal. And some other methods include the electroplating. Electroplating, basically the metal surface is get electroplated with other inert or passivating material, which prevent the exposure of metal to the atmosphere and in turn helps it from being get corroded. So these electroplated material may include the metals such as the magnesium, chromium, titanium and zinc, which forms the similar protective oxide coatings on the surface of the metal, and underlying iron or a metal this layer prevents from exposure to the environment, and underlying matter prevents from the oxidation and in turn from the corrosion. These corrosion materials are in turn provides the strength to the material, just like in certain aircrafts the advanced materials helps not just to being prevent from corrosion, but also provide the strength to the material. For example, the steel which is used in the automobile is coated by dipping it into a bath of molten zinc, and due to the process of the galvanizing, an zinc oxide layer is formed on the surface of the steel, which will prevent it from the corrosion process. And not also the metallic coatings, some non-metallic coatings can also be used to prevent the surface from the corrosion, and that non-metallic coatings may include the plastics, paints, oils, and they help to reduce or to prevent the corrosion process.
Paint the areas exposed to oxygen and moisture. This is done on many bicycles and cars. Another method to prevent rust is by placing a layer of oil or grease. This is done on many bicycle chains. It helps lubricate the moving parts, which reduces friction and slows down the rusting process. Another way to prevent rusting is a sacrificial protection method called galvanizing. Have a look at this reactivity table. Zinc is more reactive than iron. When exposed to oxygen and moisture, zinc will corrode faster than iron. So if we put them together, zinc protects iron but is sacrificing itself, hence the term sacrificial protection. This method is applied to prevent rusting on ships. The oxidation of zinc can be described using this following equation. So besides preventing rusting, there is another advantage to this galvanizing process. The formed zinc oxide layer can be removed, and the freshly exposed zinc can corrode once again.
So we will see that how the galvanizing or sacrificial protection layer helps our metal, our desired metal, from being get corroded. These are the certain ways to prevent or to control the corrosion. So that the topic was about the advanced materials, properties of the advanced materials. In our next part we will discuss about how advanced materials helps in doing all these ways to prevent corrosion. And what does these advanced materials do? They form the thin film coating, and this coating includes the nanomaterial coatings, and these are very helpful in certain cases. That includes the aircraft, ship buildings, which are mostly exposed shipbuilding because ships are all the time exposed to the water and the moisture and oxygen. That's why they are easily get corroded. So to avoid their corrosion, we will use the advanced materials which helps them to avoid the corrosion process, and we can done it by the sacrificial coatings or galvanizing or by painting the surface of the materials. And in aircraft, that also includes some strength in addition to prevent them from corrosion, and our advanced materials helps this corrosion and also provide the strength. And in certain areas that where is the high temperature environment is applied, so materials get easily corroded. So in order to prevent that corrosion, we will also use the advanced materials so that the corrosion process is prevented and our material, our metal is get preserved for a longer time and its durability can be enhanced. So in the next part we will discuss about the advanced materials that are used to inhibit this corrosion process. So this is all about today's topic, and hope you will understand it and go through it. Okay, thank you and Allah Hafiz.